Good morning students. Today I'll be discussing regarding the multinomial theorem. In the previous session we have discussed regarding the binomial theorem, which involved only two terms x and y. In the multinomial theorem more than two terms will be involved, and that expansion is explained over here. So when you have the expansion of this form, that is when you have more than two terms like x1 plus x2 plus x3 so on till xk to the power n, then this is the coefficient for all the individual terms. So we had already solved this type of problem, so that can be represented in this way I had told. So here the expansion is x1 plus x2 plus x3 plus so on till xk to the power n. Then you should write the coefficient of this individual terms as n factorial divided by n1 n2 so on till nk. So this will be the coefficient where n1 nk all are non-negative integers, and remember this whatever these n1 n2 n3 so on till nk should not exceed the value of n. So the addition of all these terms should be equal to n. Remember that are not exceeding n, and n1 plus n2 plus n3 so on till nk is equal to 1. The expression this is also written as this way, and this is nothing but the multinomial coefficient of these terms. So remember x1 plus x2 plus x3 plus so on till xk to the power n can be written in terms of n, n1, n2, that's all till nk, and then it is written as x1 to the power n1 into x2 to the power n2 so on till xk to the power nk. Now the coefficient of these term is nothing but this, and the expansion is this. Now while solving the problem we'll get to know how we are supposed to solve. So let us go to the example 1. Here they're told that find the coefficient of xyz whole square in the expansion of this. So what you're supposed to do is first try to expand this, then like similar how we did in binomial, try to expand this, then you're going to find the coefficient when corresponding to this particular term. So let us solve this particular thing in the new page. So determine the coefficient of 1 x y z square xyz square in the expansion of 2x minus y minus z to the power 4. 2x minus y minus z to the power 4. Now when you try to solve this particular problem, it would be nothing but how will you write the expansion of this 2x? So by the multinomial theorem, right over here, by multinomial theorem, the expansion of the expansion of 2x minus y minus z to the power 4 is nothing but, you know that n, what is n is 4. What is n1 n2 n3 we don't know. We don't know the value of n1 n2 n3, because see over here in the theorem itself, just check in the theorem. Here we had n factorial, and here it is n1 n2 nk. We don't know the n1 values, we just know the n values, so I wrote 4 over here. Below you just write n1, since there are 3 terms, write n2 comma n3. Okay, so this is one part, and then you know x to the power n1. So what is in the place of x? It is nothing but 2x to the power n1. And what is in terms of y? Minus y to the power n2. And what is in terms of z? It is minus z to the power n3. Okay, so this is the section. Now now what you got, this is the expansion you got. Now for what values of n1, n2, n3, okay, we'll get it as the coefficient of these terms. So here they are told x to the power, find the coefficient of x to the power 1, y to the power 1, and z to the power 2. So can I substitute here n1 as 1, 1 and 2, and yes, it is equal to n value. So for n1 is equal to 1 and n2 is equal to 1 and n3 is equal to 2, this becomes 4, 1, 1, 1, okay, and then this would be 2x to the power n1. What is n1? 1. Sorry, here n3 is 2. Okay, n3 is 2. I written 1. 2x to the power 1 minus y to the power n2 is, what is the value of n2? It is also 1, and minus z to the power value is n3, so it is 2. So this can be written as 4, 1, 1, 2. 2x to the power, will make all 2's together, I mean x, y, z together, 2 to the power 1 into minus 1, let us, that x let it be here, y I took here, y ka minus 1 I kept out, and z minus z square, it is what, into minus 1 whole square, and here it would be z square. So it is nothing but minus z square is z square itself. So xyz square I got, right? Xyz square, that is what is required here, xyz square. So what if I, in the sense, what if I substitute over here, I will get this particular section here to see. So x to the power 1, y to the power 1, same like how we did binomial, z to the power 2, I'll get it as what, xyz square. So here I got that particular term what is required over here. Then you find the coefficient. Therefore the coefficient is, the coefficient of xyz square is 4, 1, 1, 1, sorry, it is 2, and here it is 2 to the power 1 multiplied by minus 1, and then 1 minus 1 whole square. So this is nothing but 4 factorial divided by 1 factorial, 1 factorial, 2 factorial into 2 into minus 1. 1 square is minus 1 whole square is 1 itself, so minus 1. So this 2 gets cancelled. So it is nothing but 4 factorial. It is actually minus 4 factorial. So it is minus 4 into 3 into minus 4 into 3 into 2 into 1. So 4 3s are 12, 12 2s are 24. So answer is minus 24. So this is the coefficient of xy z square. So I'll just repeat. Find the coefficient of xyz square in the expansion of this, they have told. So there are only 3 terms and to the power n. So you know the formula of multinomial. It is x1 plus x2 plus x3 plus so on to the power n. That can be written as n followed by how many terms are there? 1, 2, 3. So I wrote 4, 1, 2, 3, n1, n2, n3. Then you know it is x to the power n1, y to the power n2, z to the power n3. So instead of x I have 2x, instead of y I have minus y, instead of z I have minus z. Now just try to put such that you will get x to the power 1. I can put n1 as 1, y to the power also 1 I should get. So I took minus 1 common and y to the power 1 itself I'll put, and z to the power also I should get it as 2. So I put n1 is equal to 1, n2 is equal to 1 and n3 is equal to 2, and I substituted, and then I got xyz square, and this is the coefficient. I further solved and I got this particular result. So this is regarding the example 1. Find the coefficient of xyz square in the expansion of 2x minus y minus z whole to the power 4. So let us solve the example 2. So example 2, they have told find the coefficient of x square, y square, z cube in the expansion of 3x minus 2y minus 4z whole to the power 7. Okay, so let us solve this in a new page. So the question is x square, y square, z cube in the expansion of 7. Okay, so let us try to solve this. So the expansion of 3x minus 2y minus 4z whole to the power 7 is nothing but n is 7. Totally there are 3 terms, so n1, n2, comma n3, n1, comma n2, comma n3. Then x as it is, so it is 3x over here, 3x to the power n1, and y is minus 2y to the power n2, and z is minus 4z to the power n3. Okay, so this is the expansion. Now here itself let us try to separate this. 7 I wrote as it is, n1, n2, comma n3. Try to separate x and this separately, so it is 3 to the power n1, and let me take minus 2 over here, minus 2 to the power n, minus 2 to the power n2, and let me take minus 4 to the power n3. I took all the coefficients out, and here I'll write x to the power n1, y to the power n2, and z to the power n3. Now this is the form. Since directly we want to find x square y square, so I'll just substitute for n1 is equal to, when you substitute n1 is equal to 2 and n2 is equal to 2 and n3 is equal to 3, you will get this itself, x square y square, and this is the coefficient. So let us substitute this. So this becomes, so this expansion turns, this expansion is now, expansion is 7 n1 comma n2 comma n3. Sorry, we have to resolve the n1 n2 values, so it will be 7 2 comma 2 comma 3, and here it would be 3 to the power 2 minus 2 to the power 2 and minus 4 to the power 3, minus 4 to the power 3, and then here it would be x square, y square, and z cube. So you can solve this particular problem. It would be 7 factorial divided by 2 factorial, 2 factorial, 3 factorial. 3 into 3 is 9, minus 2 square, it is minus 2 into minus 2 is 4, and here it is minus 4 cube. It is nothing but you'll get it as minus itself, so I'll put that minus over here. I'll put that minus over here. I'll just get that minus out. Here it is 4 cube, so it is 4 cube is nothing but 4 into 4 into 4, it would be 64. I'm just writing the coefficient of this. Okay, the coefficient of, now you got this term, here you write the coefficient is the coefficient of x square, y square, and z cube is this term. So I wrote this particular term. Try to solve this. So you know that 4 this and this gets cancelled. 3 into 2 it is, so I'll just solve here. Minus 7 by 3 into 2 into 9 into 64. So you know 2 ones are 2 3s are and 2s are, and 3 1s are and 3 3s are. So it would be nothing but minus 7 into 3 into 32. So you'll get it, the answer as minus 672. So this is the, so you'll get the answer as minus 672, I guess. So I'll just check, cross verify once again. 7 2 3 3 square minus 2 whole square is this, and minus 4 cube is the answer. So here 3 square is 9, minus 2 it would be 4, and 4 cube is 64. So I took minus out. Here it is 7 factorial divided by 2 factorial by 2. So if I just solve this, you'll get it as, I'll just solve this again. 7 by 2, and this 2 and this 2 I cancelled with this. So left out was 3 into 2. 3 into 2 is 6. 3 into 2. So I took 2 ones are, 2 3s are, and this would be 2s are. So it is 32. 32 into 3 ones are 3. 32 into 3 into 7 we got. 32 into 7. So you'll get the answer as minus 672. Sorry, this factorial we did not solve, that's why sorry, minus 7 factorial we did not solve itself. So you have to solve the minus 7 factorial. I just multiplied with minus 7, so the answer will change actually. It is minus 7 factorial, so I missed the 7 factorial. So the answer would be minus 4 into minus 483,840. Okay, so this is the answer. Sorry students, I just missed the factorial here. So you have to solve this factorial and find what is 7 factorial and then multiply with 3 into 32. That itself is the answer. So this is regarding the example 2. Now let us solve the example 3. In the example 3, he has told find the coefficient of x to the power 11 and y to the power 4 in the expansion of this way, that is 2x cube minus 3x y square plus z square to the power 6. So let us solve in the new page. So the question is x to the power 11 y to the power 4 in the expansion of 2x cube minus 3x y square plus z square to the power 6. 2x cube minus 3x y square plus z square to the power 6, x to the power 11 and y to the power 1. So the by multinomial theorem, the general term expansion is expansion of 2x cube minus 3xy whole square xy square plus z square to the power 6 is nothing but n is what? N is 6, right? How many terms are there? 3 terms. So n1 comma n2 comma n3, that into whatever is the x sum. So it is 2x cube to the power n1 and next term is y term is, instead of it is 3xy square to the power n2 and z term is z square to the power n3. Okay, z square to the power n3. So check here, what if I resolve? I'll get x to the power 11 and y to the power 4. I'll just try to separate it. So 6 n1 comma n2 comma n3, this I'll just separate the terms. So it is 2 to the power n1 and then here I'll 2 to the power n1, that's it, and here it would be minus 3 to the power n2 minus 3 to the power n2 minus 3 to the power n2 and n3 is nothing but 1 into 1 to the power n3. Okay, let it be as it is, 1 to the power n3. Now write x terms together. So it would be x3 to the power n1 and xy square to the power n2 and z square to the power n3. Now you know here z is not there. So what it should be the value of n3? Obviously if you substitute n3 equal to 0, then z will be z to the power 2 into 0, so z to the power 0 is 1. So z term itself will be deleted. So we should take by taking n3 equal to 0, then z term will not be there. Now why you should get 4? Here 2 is there, here n2 is there, so n2 should be already y to the power 2 is there, again you need 4, right? So it should be what? n2 should be equal to 2. n2 should be equal to 2, so that will be y to the power 2 into 2, it would be 4, and see xy squared 2. So you'll get this value as x square and y to the power 4. Now you got x square, so 2 is done. Remaining here value should be what? Here you should have your x square you got plus 9 will give you what? 11. So 9 should come total here for this x, 9 should come. So what should be the value of n1? n1 should be 3. n1 should be 3. So this equation will turn into nothing but 6. n1 is 3, n2 is 2 and n3 is 0. So this you'll get. After that 2 to the power n1 is 3 into minus 3 to the power n2. What is the value of n2? n2 is 2 and into 1 to the power 0 n3, and then here it would be x 3 to the power n1 is 3. Okay, n1 is 3, and here again xy square, n2 is 2. This is square, okay, x square, and here z square to the power 0. So this would be nothing but 6, 3, 2, 0, and 2 to the power 3 into minus 3 to the power 2, and 1 to the power 0 is 1 itself. So it would be x to the power 9 plus this x square would be x to the power 11 y to the power 4. So now this is what is in the required form. Therefore, the coefficient of x to the power 11 y to the power 4 is 6 factorial divided by 3 factorial, 2 factorial, 0 factorial into 2 to the power 3 into minus 3 to the power square. So this is the coefficient. So it would be nothing but that 6 factorial, I can get it into 6 into 5 into 4 into 3 factorial divided by 3 factorial. So this and this gets cancelled, and here 2 factorial into 2 into 2 into 2 of this 2 cube, and minus 3 square is nothing but plus, it is 9. So 2, 1 and this 2 got cancelled. So it is nothing but 6 into 5 into 4 into 2 into 2 into 9, you will get it as. So just try to multiply these values. So you'll get it as 6 into 5 is nothing but 30. 30 into 4 is 120. 120 into again 2 into 2 is 4. 480 into 9, you'll get it as 4320. You get it as 4320. So this is the coefficient of x to the power 11 y to the power 4. So this is regarding how to find the coefficients of multinomial expansion. So how to find the coefficients of multinomial expansion. So these are the 3 examples under how we are going to find the multinomial expansion. Thank you. So this is regarding binomial and multinomial theorem.